All right, here we have three more non-calculator questions, this time about limits. I always try when I'm getting a limit at a point, so like x goes to 0 here, try direct substitution first because that's your most obvious way of handling it. And so if you can, directly substitute in, you get 0 minus sine of 0, which is 0, over 0. So we have 0 over 0, which is an indeterminate form, and therefore we have to use L'Hopital's rule. So you see here that I wrote down my h with the circle to let the reader know that I'm actually transforming the limit expression using L'Hopital's rule. So I differentiate x minus sine x to 1 minus cosine x, and I differentiate x cubed to 3x squared. Then I do direct substitution again, and I get 1 minus cosine of 0, which is 1, all over 0. So once again, I have an indeterminate form, so I can apply another round of L'Hopital's rule. So when I do that, my negative cosine x goes to sine x, and my 3x squared goes to 6x. So I do direct substitution again, and I get sine of 0, which is 0, over 0. Once again, I have an indeterminate form, so once again, I apply L'Hopital's rule. This time I'm going to get somewhere because sine differentiates to cosine, but 6x goes to 6. So when I do direct substitution, cosine of 0 is 1, and my denominator is 6, so my answer is 1/6. Number 5 is a limit at infinity, and I've got a rational function with x going to infinity, so I really just need to look at the degree of the numerator and denominator. So my degree is the biggest degree of each, so I have a squared on top and a squared on bottom, which means I just need the ratio of the leading coefficients, and that ratio is -2 over 3. So -2/3 is my answer. No work needs to be shown for that. For number 6, once again, I'll try direct substitution, and I'm going to get 2 to the 0, which is 1. So I have 1 minus 1 over 0, and of course that's 0 over 0, so I need L'Hopital's rule. So I'm going to differentiate 2 to the negative x to get the natural log of the base times 2 to the negative x times the derivative of negative x, which is this -1. And -1 differentiates to 0, and x differentiates to 1. So now when I do direct substitution, I have the negative ln of 2 times 2 to the 0, and I'm just left with the negative natural log of 2.